Start. Okay, so what we've done before is I've given you graphs and asked you information about graphs, correct? Or I've given you equations and asked you information about equations. But now what we're doing, our last thing, is to give you a graph and ask you for the actual equation. So when your graph has just asymptotes, so just one vertical and one horizontal, the fastest way to come up with the equation is actually putting it in the transformed form. If there's a point of discontinuity or there's two vertical asymptotes, we can't use this form. Okay? Now, every single time we've determined an equation throughout the year, we've always had an a value in front that we've had to look for. It was our vertical stretch, correct? We've always had to look for that. Still is not different. We're going to have to do that again. So the first thing let's do is let's put in our asymptotes. And remember, we can only use the transformed form when we have just a horizontal and just a vertical. So our horizontal asymptotes on y equals 0. Has it moved? Has there been any transformations? Remember, this is the transformed form. Where do our asymptotes sit if they're not moved? At y equals 0 for horizontal and x equals 0 for vertical, correct? Where are our asymptotes on this question? Y equals 0 and x equals 0. So we have no transformations. So we currently have y equals a over x minus 0, bless you, plus 0. Do I need the zeros?
No.
No.
Did you do x?
Yeah. I wouldn't put any values, to be honest, if it were me. But now we need to solve for a. How have we always solved for a? Yeah. Pick a point on the graph. And I always pick a bolded point. So, so it's at -2, -2 and 2. The box thing is for radical graphs, not rational graphs. Okay, so we have x, y. So we have 2 equals a over -2 plus 0, which I don't need the plus 0, so I'm going to ignore that. And then I'm going to multiply by -2. And I'm going to get a equals -4. Remember I told you that the original graph is also down on the left and up on the right? So we knew that this was going to be negative for sure because the quadrants are opposite. So we're going to get y equals -4. And remember I told you, if you just say a equals something but don't rewrite the equation, you actually have not gotten full marks because you didn't give me an equation, which is what I asked for. Write the equation over x. So when you only have a vertical asymptote and a horizontal asymptote but no point in discontinuity is the only time you can use this. If you have a point in discontinuity, you cannot use this form. Don't try it. It will not work. You'll have an open dot. Yeah, which is on the next one. Okay. We have an x-axis, which is at y equals 0. And then we have an x asymptote, so horizontal at y equals 0. And we have a vertical at x equals -3. I got to put the y equals 0 on this side. Okay. Guys, I'm recording, so shh. All right. So we have y equals a. Is x still at 0? Do I still have x equals 0 as my line? No, it's been moved 3 to the left. So what am I going to have on the bottom? X plus 3. And then is my vertical or my horizontal still at y equals 0? Yes. If it wasn't, say it was at y equals 2, I put a plus 2 at the back, right? But I don't have to put anything because there's nothing. So now I find a bolded point, -2 and 1, and solve for a. 1 equals a -2 plus 3. 1 equals a over 1. A equals 1. So I get y equals 1 over x plus 3. Okay? Circle C and D for homework. And we're flipping over to the other page. Because all we've done is examples where it's just a vertical and a horizontal asymptote. Okay? What if we get one with a point of discontinuity in it? Oh my. Okay. So these are your circle C and D. Now, let's go over what the equation of, we'll go into the other page in a second. When we look at any equation with a point of discontinuity, what do we know about it? How do we know we have a point of discontinuity? We have two factors that cancel, right? So if we had a point of discontinuity, a P of D, which you cannot write on the diploma, you have to write point of discontinuity, the factor would be on the top and the bottom. We agree? Okay. So we would find our point of discontinuity and say it's at 3. We put x minus 3 on the top and the bottom, right? Okay. What's also down here? What could be down there as well? What's your other NPV? Your vertical asymptote. Okay, your vertical asymptote's the other factor. Hi, killing me. You're not, but you're always the common denominator. It's true. You can't even deny it. It's reals. It's a math joke, yes. Okay. On the top, what's left behind? Most people won't figure it out. But say I had this. Say I have y equals x plus 3, just a basic one, over x minus 4. Okay? What actually is left behind at the top is your x-intercept. Because watch. If I fill a 0 in, I'm going to get x plus 3 over x minus 4. And then this is just going to cancel because I'm going to add it up here, right? So that's gone. And then I go x equals negative 3, right? Which is my x-intercept. Yes? So what you need to remember is these are points of discontinuity. This is true. This is your vertical asymptote. But this is your x-intercept. And what else do we always need when we're finding an equation? Every time we found an equation, what did I tell you we have to look for at the end? Starts with an A. It actually is the A value. It starts with an A, it is A. You have to look for an A every single time. Your vertical stretch. Yeah. Because when you bring an entire factor up and multiply it by 0, it's 0. Yeah. Because it's the x-intercept, so y is 0. All right. Here. 7. Let's state what we do know for 7. We know we have a point of discontinuity, a P of D. Can we write P of D on the diploma? No, you can. It will not be pretty. I would not suggest it. Bad things will happen. Okay. Point of discontinuity is at 0 and 3. We know we have a vertical asymptote at x equals negative 2. In that equation, did I put a horizontal asymptote anywhere? No, don't care what it is. But we do need what else? Our x-intercept, which is at negative 6, 0. To find our A in these cases, find A, we're always going to use our P of D, just so you know. Little side note. So you're going to give me all that information on the previous page because I can't fill it in here. So I have a P of D at 0 and 3. I have a vertical asymptote at x equals what? Negative 2. I have an x-intercept at And that's all the information I need because I can use my point of discontinuity to find the A value. Okay, so the x of the point of discontinuity gets you the factor, correct? That's going to cancel off. So my x is actually x equals 0. So I don't need to work. If it was x equals 3, I'd have x minus 3. If it was x equals 10, I'd have x minus 10. If it was x equals negative 4, I'd have x plus 4. Okay? If it's just x equals 0, what's my factor? Just x. So I'm going to get y equals a, because that I'm always going to have. And my point of discontinuity is x and x. So I need to have a factor on the top and the bottom. Think about it. If the factor x canceled off, what would be the x of my point of discontinuity? 0. No, we use the 3 to find the a. Okay, so we put in our point of discontinuity, top and bottom, right? Then we put our x-intercept on the top. Our x-intercept is at x equals negative 6. So what's its factor? X plus 6. On the bottom, we put our vertical asymptote. It's x equals negative 2. So what are we going to put on the bottom? X plus 2. Now we need to solve for our a. When we go to solve for our a, we get rid of our point of discontinuity fractions, those factors, and we'll plug it in and solve for a. So to solve for a, we cancel our P of D factors and substitute our point of discontinuity in. So to solve for a, to get the equation, we're still going to have it in this form, right? The same form. But to solve for a off to the side, we're actually going to plug it into the form without the points of discontinuity. So a, x plus 6, x plus 2. And we're going to plug in the point of discontinuity for our x and our y. Why did we have to get rid of those x's first? Because if we plugged in our point of discontinuity with those x's in it, we get a 0 on the top and a 0 on the bottom. If your a is a value of 0, you messed up, because that's not possible. It would cancel the whole equation out. So we're going to get 3 equals a, 0 plus 6 over 0 plus 2. So we get 3 equals 6a over 2. Then we can multiply by 2. 6 equals 6a. Divide by 6. And a equals 1. A is not always 1, though. If a is 1, do I have to write it? No. A is technically 1, but I wouldn't have to write it. They're not going to give you the answer like this in the factored form. They're probably going to distribute back. So the answer you're going to get is x squared plus 6x over x squared plus 2x. What's great about equations and graphs? You can type it in and see if they match. So you have to put in your points of discontinuity factors, your vertical asymptote factor, your x-intercept factor, solve for a using the point of discontinuity with those factors out every single time. But if it's just an asymptote, vertical and horizontal, you can just plug it into the transformation equation. Okay. This one. B you're going to do on your own for homework. We're going to look at B here. 8b. A vertical asymptote of x equals negative 4. A point of discontinuity at negative 11 over 2 and 9. And an x-intercept at 8. Now, just so you know, we had to pull those 3 pieces of information off the graph, didn't we? Yeah. They're just nicely giving it to us. That is nice. So, we're going to go. All right. So we need y equals a p of d, x-intercept, p of d, vertical asymptote. And we have a vertical asymptote at x equals negative 4. We have a p of d, or a point of discontinuity, at negative 11 over 2 and 9. And we have an x-intercept at x equals 8. Okay, we have to work them all back to factors. Yep.
When you write that, if you write that formula down to solve for it on your diploma, do you have to put like P and D? Or like you have to put like.
They aren't going to really care. They're going to care what you filled it in correctly.
They don't care what you.
Because it's not, well, it's not an actual, yeah. They wouldn't give you a part mark for it because you have no work in it anyway. So it matters that you fill it in properly. Yeah. So we have y equals a. What's the x of my point of discontinuity? Negative 11 over 2. So what is it as a factor? Yes, you actually got it right. Most people will tell me it's x plus 11 over 2. It's x equals negative 11 over 2, right? If that was an answer, what did we do to get there? Well, we actually divided by 2, so we're going to have to multiply by 2. And then we have to add 11. So that's going to be our point of discontinuity part. 2x plus 11. My x-intercept is at 8. So what is it going to have? X minus 8. And then my vertical asymptote is at x plus 4. How do I solve for A? Write the equation without the points of discontinuity. And what do I plug in? Your point of discontinuity. So I'm going to go 9 equals A negative 11 over 2 minus 8 over negative 11 over 2 plus 4, which gets me 9 equals A. Negative 11 over 2 minus 8 is negative 11 over 2 minus 16 over 2, which is negative 27 over 2. Negative 11 over 2 plus 4 is negative 11 over 2 plus 8 over 2, which is 3 over 2. Negative 3 over 2. Then I'm going to multiply by negative 3 over 2. Some of you flip it. If I'm multiplying, I'm not flipping. So I get negative 27 over 2. Stop. Negative 27 over 2a. Divide by negative 27 over 2. A equals 1. We always have to check for A because I've seen it before where A is not 1, so you can't just assume it. If you forget to solve for the A and A is not just 1, they'll have the answer to just 1 there, right? So our answer is going to be y equals, this would turn to a 1, which does nothing. If it was a 2 or something, we'd have to FOIL first, then distribute that in, right? So we're going to get 2x squared minus 16 plus 11, so minus 5x minus 88 over 2x squared plus 8 plus 11, so plus 19x plus 44. So your homework is the last two of number 7. Actually, no, like the very first page. So the last two of number 7, this is your homework, C and D. And then of this page, you have to do 7B and then 8A, C, D of page 452 and 450. Page 453 is this one in your textbook, 7 and 8. And the other one is page, it's an earlier page, 443. They look like they're together, but they're not. Page 443. They're from 2 separate lessons.